is the number of different ways that a certain number of objects can be selected as a group from a larger number of objects. If the order is not important, you are dealing with a combination. And then the equation is n factorial over n minus r factorial r factorial. Okay, so let's now do some examples with this. Oh, okay. We're not ready? Now? Okay. All right. How many groups of 3 students can be selected in a class of 30 students? Since the order does not matter, in this question, we're dealing with a combination where n equals 30 and r equals 3. Okay? So, we want to do, remember we are recording. We're going to do 30 factorial over 30 minus 3 factorial, 3 factorial. So again, I would put that in my calculator, and I would do the control division sign again, so it comes up. Remember, I am recording, and everything you're saying shows up on here. Okay, and I'm putting that in. Yes?
What does n and r equal?
N is the number of objects, and 3 is the size of the group you can put in it. Mm-hmm. So we're looking for groups of 3. So that's why R is 3. No, it's not big enough that it needs to be inside second notation. We get 4,060 as our answer. The size of the group. Okay, now what we're going to do is we're going to go through last night's homework, and we're going to do the combination one. Yes? N is the number of people. R is the size of the group. Okay, so let's pull back out last night's homework. And we're going to do the ones that are combinations. Number 1 was a permutation, but number 2 was a combination. So let's do number 2. How many photos are there? How many groups do we want of them? The size of the group is 10. So that's R, that's N. So that's 500 factorial over 500 minus 10 factorial. 10 factorial. Okay, it does say it's too big, so let's see if we can do it in pieces. What's 500 minus 10? Yes?
490.
R is the size of the group, and the size of the group we're looking for is only 10. Does that make more sense? Okay. Let me see if I can do this. All right, it's telling me it's too big. So we're going to look at a smaller one to try to do it. I feel like the calculator, there's a little, there must be something in settings we can change, but I don't know what it is right this second. So let's look at 5. 5 is also a combination. All right, why don't you guys right now try to do 5 and 7? So 5 and 7 right now, try to set it up and stick it in your calculator and see if you can make it work. And I'm going to give you like 2 more minutes, and then I'm going to have a volunteer tell me at least how to set it up. Okay, guys, how are we going to set up number 5? Anybody want to try it? 350 factorial over. And what do we get as our answer?
4, 2, 5, 3, 0, 1, 6, 2.
Okay, so I'm just going to round it to 4.3 because it's way too many. Right, so I'm just rounding it to 2. So since it's 4.25, I'm rounding it to 4.3 times 10 to the 10th. Okay, yes, Ethan?
I got 1.2056 times 10 to the second.
For number 5 or number 7?
Oh, that's
That was 7? Okay. So, let's look at 7. You have a team that has 45 players, and only 9 are given playing time, okay, at a time. So that we've got 45 factorial over 45 minus 9 factorial over 9 factorial.
Can you put it in your calculator just like that?
You should be able to.
No, you
So-
have to use parentheses at the bottom. Like,
Yes.
parentheses around the whole bottom.
Or you can make it, or again, you can hit Control division sign, and it'll give you a fraction. And then you can just put 45 factorial over 45 minus 9 factorial, 9 factorial. But that only works if you do it like that. Otherwise, like Cheyenne said, you have to put another set of parentheses here. I get 8.8 or 9, I could round it up to, times 10 to the 8th. Let me see. If you got a different answer, I'd love to see and show you an example. Come here. Nick, did you get a different answer? Do you still have it in your calculator?
What should we get?
Yeah, bring me your calculator. Okay. So, you guys tell me. I'm using Nick as an example, and Nick's not going to take offense at all because this is brand new, right? Okay, what is Nick missing from this equation? On the top.
Oh, yeah.
Okay. Anybody else got a different answer than Nick had? Come here, Mike.
I did, but
This is really important. We have to know how to plug things in the calculator, right?
yeah.
So if you get something wrong,
You
What
laughing
did-
at me?
I am laughing at you. What did Maya
What should
do
we get?
differently on hers?
Put 5 instead of 9.
Yeah.
What did
Oh.
you get? What was your answer?
It's 8.9 times 10 to the 8.
Why you couldn't just tell me that and have me turn around? You ain't right.
Okay. I just rounded it. You have the same thing. You have 8.861, blah, 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 blah. I just rounded it.
I had 8 billion.
Yeah, if you hit Control Enter, it gives you a scientific notation. Okay. So now we are going to work on permutations versus combinations, death march. Okay. I don't know why it's labeled death march.
That's
It's supposed to be.
I'm pretty sure that's match.
I changed it to March. You're right, it is March. Mine's more fun.
I don't know. That's match.
Death match is better.
Yeah, my brain feels.
Okay. So, ladies and germs,
Not a germ.
I'm just being ridiculous. I had to explain to my 4-year-old what a germ was yesterday. It was very confusing. Okay. Using the permutation list above, put them into groups that contain the same 3 letters. Okay, so watch. This is what I'm doing. RST, so I want to highlight every single one that has an R and an S and a T in it. RST, circle it with your pencil. Okay? Now I'm going to make a different group with NSR in it. Okay, this one has an N and an S and an R. So does this one. This one has an N and S and an R. So does this one. And these have N, S, and R. Okay. I'm going to, in a different color, circle the ones that have R, a T, and an N. And finally, I'm going to circle the ones that have an S, a T, and an N.
Wait, hold on, go back.
Okay, so before we circled them, how many different ones were there? Just count. 1, 2, 3, 4, 5, 6, 7. How many are there? Who knows how many there are? How many? 24. We can also write this as how many different letters can we use? How many different letters? R, S, T, and N. So there are 4 things, but we can only put them in groups of 3. 4, permutation 3. 4 groups, but they can only be in sets of 3.
So if you put that in the calculator, instead of the thing, you just put as the exclamation.
No, you would have to change it to that equation where it's 4 exclamation mark over 4 minus 3 exclamation.
Why you put that
letters calculated.
Why do we put that in it? Because if we
No, is that how?
this.
Put a P.
Yeah.
No, we don't. I'm just telling you that it can be written like this, and then that's what you have to do.
Okay. Okay.
I didn't make that clear at all. All right. How many combinations are there? So order doesn't matter. So how many groups do we have? A total of
Oh, wait.
1 group,
Oh.
2 group,
Four.
3 group, 4. And we write this again as 4 possibilities, possible letters. But it's a combination of a group of 3, and we get 4.
Oh,
Okay, go ahead.
Is that a C?
yeah, that's a C.
Okay. Before we move on, any questions about that? Okay. Remember, combinations are 4 factorial over 4 minus 3 factorial, 3 factorial. And that will give you 4. In case we don't want to write them all out, because that's 4. How many different permutations are there? For number 4. Right? So I'm counting. 1, 2, 3. So let me read the whole problem. For problems 4 and 5, use the list below of all the permutations for the letters R, S, T, and N, and K, but you can only use 2 at a time. Okay, so how many of them are there? 20. Okay, and this is, how many different letters could we have possibly used? There was 5 possibilities, right?
Five.
But we could only make them in groups of 2. All right? So if we didn't want to write them all out, remember, we could have written 5 factorial over 5 minus 2 factorial. How many combinations are there? So order doesn't matter. So this is just 1. So there's 1. Here's 2. Here's 3. How many of them are there going to be? 10. And that's 5 combination 2. So that means we go 5 factorial over 5 minus 2 factorial, 2 factorial. And we'll get oh, we're going to stop here. Your homework is on the board. It is page 686, 3, 4, 11 through 14, 25 through 28, 34 through 37, 47, 50, and 69.